Okay, last talk of the day. I want to thank you all for coming today. Our last talk is going to be on future storage needs and some customers' perspectives. We have a distinguished panel here. We'll start off with Lee. Lee Prewitt is Director of Cloud Hardware Storage with 30 years of storage industry experience, ranging from magneto-optical to spinning Rust to Flash. His former work at Microsoft has included working on the Windows and Device Group, where he was responsible for many of the components in the storage stack, including file systems, storage port, and Microsoft's inbox mini drivers. His responsibilities include storage devices ranging from SD and UFS in mobile to NVMe in enterprise and data centers. He currently works in the Azure Hardware Group, where his team is responsible for future data center storage initiative and specifications and evangelization. Next up, we have Paul Kaler here. He brings over 20 years of experience to his current role as a future storage architect for future server architecture team at HPE. He is responsible for researching and evaluating future storage and interconnect technologies and defining the server storage strategy for Reliant servers. He has previously led development of SSD storage arrays, been a founder and co-founder of a couple startups, and helped develop the first dual-screen smartphone. Paul is also actively involved in multiple standards and industry organizations, has been a key driver of standards including U.3, EDSFF E3, and the OCP Data Center NVMe SSD spec. Then we have Chris Sabol at Google over here. Chris is a software engineer and an SSD architect at Google. He has led development of Google internal SSDs and more recently focused on aligning Google with SSD industry standards. Prior to Google, Chris worked on networking as chief architect at TwoWire. He has an MS in computer engineering from Carnegie Mellon University, where he focused on storage systems. And lastly, I'm Ross Stenfort at Meta, focused on storage and how do we build better storage systems. And with that, how about if we go ahead and get started here? I think, Paul, you're up first with some thoughts.
So, all right. All right, so I wanted to share a couple of trends that we've been seeing and some things that HPE sees as future storage needs. And some of them may ruffle some feathers, but I think that's what we're up here for, to kind of talk about what we want to see in the future. So I think everybody here has been aware of the rapid growth that we've seen in NAND die size. One of the challenges that we've been seeing is that the NAND performance has not been keeping up with that. And so we're starting to see challenges with gen over gen performance from drives. The next drive family, typically we've seen performance improvements over time. We're not seeing that anymore, and especially with some of the lower level capacity points, we're really seeing some challenges getting a reasonable performance for that low end capacity point of a drive family. So we'd really love to see just increased innovation around improving the actual NAND performance, because of course as those densities go from 512 to 1 terabit to 2 terabit, you don't need many more die for those low capacity points, and so really love to see the performance scale as quickly as the capacity scaling. And then boot focused, we have the OCP boot spec today. We'd really love to see, today a lot of drives kind of go into the boot space for customers that are basically just the low end capacity point of an existing drive. But we really like to see a focused product around boot, because they do have unique requirements. And looking here like at 240, 480 gig kind of capacity points, that's really all we need for boot. They have kind of very specific performance and endurance requirements. Those are in the OCP spec. For enterprise, we kind of have one big requirement on top of that, and that's to add power loss protection. So we'd love to be able to leverage a lot of the stuff that's going on in the boot spec for OCP with maybe just PLP added. So again, we'd love to see kind of a focus on boot specific products. Now I'm going to touch on some high performance NVMe that we see with PCIe Gen 5 coming just around the corner. We've had kind of two mainstream kind of and high performance two classes of NVMe drives. And What we're seeing is that the segmentation between those two classes are kind of shrinking when you would expect it to be growing, right? We're going to PCI Gen 5. You would think that the performance on the high end would really be pushing the limits, and then the mainstream would kind of stay there for SAS and SATA folks that are coming over to NVMe. But we're seeing that segmentation is actually shrinking some. And some of that is because we think that they're maybe not the right form factors being used. We do see that the E3.S 2T form factor provides much higher power and thermal capabilities. So we'd love to see more PCIe Gen 5 high-performance NVMe swim lane drives utilize the form factors that give you the ability to totally saturate that interface, so we get more segmentation between those two. And then, of course, moving forward as we go to PCIe Gen 6 and beyond, we want to see continued innovations in the power and the performance efficiency so that we don't top out with form factors and have to continue throwing more and more power to get more and more performance. So we want to see, continued innovation around that power and performance capability. For mainstream NVMe, we really kind of don't want those to be over-engineered. Something that I've been saying to device suppliers for a long time now. We really need to kind of target maybe a Gen 5 by 2 performance at max, really targeting lower power at 15 watts or less, because we want customers who are coming from SAS and SATA to have an obvious demarcation point to come into NVMe. And as we start getting bleed between the high performance and the mainstream swim lanes, that becomes challenging. So CXL, right? We're going to have lots of great discussions about CXL this summit. And we have introduced a new form factor variant to take advantage of some of the performance differences between CXL and NVMe. Most of you probably know that CXL has adopted EDSFF as a form factor, so we're expecting to see lots of CXL devices in EDSFF form factors, but most of them are by 8 lane width versus by 4, which is what NVMe predominantly uses. And so if you can see the graphic here to the right, you can see that this 2x1C new device form factor that we've proposed, where you have basically a second 1C card edge. And this enables you to plug a device that needs a by 8 into an ecosystem that's designed for by 4. The server can detect that that is a 2x1C device and then reconfigure the root port so that that's not 2 by 4 lanes, but it's one single by 8. So it's a great way that we can have customers that can mix and match CXL devices with by 4 NVMe devices without having to get custom backplanes that are either by 8s or by 4s, and then they've got to try and figure out what's the right mix for that. All right, now this is the one that may ruffle some feathers, but the NVMe hard drive discussion, we just had a talk on that. We would really like to see that more align with what we see as the future of NVMe SSDs, and that's EDSFF, and specifically the EDSFF connector. So we have the same kind of use case where you need to have mixing and matching of devices for hard drives and SSDs. We've got customers that want to have a whole bunch of hard drives, and they have to have a certain ratio of SSDs for caching. Having those be 2 different connectors would make that very difficult in the future. And so we're really looking at 5 to 10 years down the road, what is the end game here? And let's try and make sure that we really focus on that long range, because hard drives are going to be here for a long time. So we don't want to make compromises that kind of get us to an NVMe hard drive for the next 3 to 5 years. We want to look at longer term than that. And to that same end, the discussion that we just had previously on NVMe hard drive, sideband. We really want a sideband with SMBus or I3C, and that's really so that we can have isolated control planes for security, specifically for the device authentication and attestation. As soon as you hook a device up to PCIe to do that, that is one way to do it, but then that device has access to your PCIe, they can do DMA reads and writes, and that becomes problematic from a security perspective. So we really want to see an out-of-band interface for that. And then from a security standpoint as well, NVMe, it's great, we have SPDM. We really want to see SPDM extended to SAS and SATA devices. And we think that OCP can help push that forward. Working with DMTF, we think that's probably the right place to go do that. So that's what we'd like to see for future. All right, thanks. I think, Chris, that's up to you.
Hey, I think there's been a lot of good talk and discussion today, yesterday on SSDs, HDDs. I think we're going in the right direction. I think we've identified a lot of good areas for future work and a lot of work that's been done. So we see that as progress, and we should continue in those areas. I think one big area of focus for us going forward is just going to be on maintaining SSDs, HDDs at scale. It's a big challenge. Like in particular, visibility and debugging. I think there's a lot that can be done to sort of get the level of telemetry and the detail out of SSDs. Maybe starting back, Google, we've had our own internal SSDs for a long time, and we've had the luxury of just exporting gobs and gobs of telemetry from these things. So, wherever there's an if statement or a heuristic in there, we put a counter in and we export it through our stack, and we have complete visibility into them. So I think working through OCP to kind of get that level of visibility at scale into SSDs, NVMe SSDs, is a big area where we'd like to see some movement on. Security is another area. I think TCG implementations and transparency in there is an area where we'd like to see some progress. Another area is test infrastructure. I think everybody up here on stage probably has a bunch of tests, right? And we all probably have a lot of similar tests, a lot of different tests, and probably there's a lot of people out there who also have a lot of test cases. And so figuring out a way to leverage that and work together to sort of build up test infrastructure is one question mark we have got here, but we'd be very interested in working on that. Other than that, there's just general, what else should be working on questions, and be open for that topic in the discussion that's coming up here. So thank you.
Great. So Lee, you want me to go through the slide and you will add in here as we go here? Your mic's not on. Wow.
It doesn't work. Oh, okay, there we go. Got to be really close.
Wow, I thought we were going to silence you. So let me offer some thoughts for Meta here. On devices, there are discussions going on with SSDs, HDDs. These discussions should continue to happen. They're happening now, and they should continue. In addition to that, let me also talk about tape and archive. It's a major part of the ecosystem. Tape is not going away. Is there value collaborating in this area? Is there interest? I would encourage you to think about it and talk to us. Also, maintaining SSDs and HDDs at scale is a challenge. And I think that's something that we should talk about, collaborating, what are the problems and solutions? We saw a talk at the beginning of the day with challenges with latency spikes and how you debug it. I heard Chris talk about debugging. There are lots of problems maintaining, and we should probably talk about what are the challenges, solutions, and how to move forward. Are there any new storage technologies that we should be talking about? I think that's something we should all, as an organization, think about and consider. And also, I should talk about process. We've talked in our group meetings about ECNs and other processes. I think that's also something that's worth discussing and collaborating and discussing. Lee, I've been standing in front of you to hide you. You've been very quiet.
So, yeah, number one, I didn't have my own slide here. Number one, because I wasn't sure I was going to make it here because due to travel restrictions. And number two, you could see, even between Chris's slide and our slide here, there's a lot of commonality and really, debuggability, security, all the stuff around testability. So I think, debuggability, somehow unfortunately runs into the smack dab into security in our data centers because we can't let stuff out of the data center that's in binary because of security reasons. And so we need to understand how we can build up really field-wide debuggability infrastructure such that we can get the rich data that we need from the drive, or the drive's going to give us, so that we can give it back to the vendor to hone into a problem and fix that problem. And then around that security, it's like obviously the security infrastructure has to keep pace, or hopefully outpace the bad guys. How do we ensure that what needs to be inside the trust zone is inside the trust zone, and the trust zone boundary is hardened against attacks, things like that. And then in that testability range, so there's we've got all our in-house tests. The vendors have their tests. We're working now to put together test specs that third-party test houses are implementing against OCP 1.0 and 2.0. So that's really cool. But are there things that we can do to shift left even more on these sorts of things where the vendors are really up in early on doing things around the OCP tests, the CDLs of the world, the frankly things like expanding on RDT. Because frankly, as we get into very small lithographies, we're finding that as we go to scale test, we're finding issues in DPPM problems because the RDT wasn't robust enough and didn't start early enough to kind of nip that in the bud. So with that, thank you.
I'm going to jump back in here because I
Okay,
forgot something in mind.
Chris,
So
take
I
it
think-
away.
Yeah, I forgot to mention our slide. We actually are going to be contributing to the OCP data center spec, so we being Google, so that's in progress right now. So hopefully we can all work to on that spec and get kind of a alignment and really reduce the number of variants we've got to support out there and make lives easier on the vendors. So
Great. We very much look forward to working with you. And with that, let me open up. There's a mic here. There's a mic there. And head to the mic, and this is your opportunity to ask questions.
I've actually been working on this, but I'm glad to hear you say this, Chris, because I think we're all testing independently, and I think testing should be applied when we do a new feature in a specification, whether it's OCP, SNIA, or NVMe. So I would like to sponsor that we change our processes to turn in the tests when the capabilities are defined initially. What do you think? What are your thoughts on that?
I think tests, I mean, on the other side of it, I think starting with some tests is great. I think it's also very organic. Like as you learn, you add tests. As you get burned, you add tests. And so having a kind of a fluid repository we can add to and build over time, I think one of the things I think is really working well, I mean, we've got a long history of our internal tests, and I got pretty good confidence once those are passing that I've got a product that's pretty solid. And so replicating that and even multiplying that by 10x by giving everybody an opportunity to contribute to that, I think is powerful. And then also getting it in the mindset of like get the tests in early is a good thing to do. Just realize they're not going to be it's going to be a snapshot in time. They're going to I think if you think that you're going to spec the test when the feature comes out and that's going to be static, I think you're going to have gaps.
No, I'm just saying, just do the basis of what the original authors thought is the good criteria as a starting point.
Right,
Testing.
right. Yeah, I mean, forcing people to think about it during the spec development process, I think, is a great thing.
Yeah.
Well, test-driven development idea in the sense of as you put the feature together, your test team should be putting together the test spec in stride. Yes, yeah, totally agree with that. Yeah.
Yes. And we'll take your question in 1 sec. I realized we forgot our call to action slide. That's what happens when you do things live. So if you have interesting topics to discuss, we have Amber Huffman from Google over here, and myself, we're co-project leads for storage. We have a link here for the storage project. It has the calendar. We have a link here for contributions. And so I encourage you all to check it out. And with that, we'll go back to our previous programming and questions here.
Thank you. So with the debuggability question, there's a lot of sideband paths into the drive. Is there any, it seems like there'd be a benefit to drive towards one. So with PCIe, VDM, management send and receive, and NVMe, and then I3C, do we see an alignment on that, or is there still a need for the various interfaces and maybe others to come?
I can touch on that a little bit. So yeah, I think there's going to be a mix of sideband interfaces, right? Some of them, as we get to I3C and faster sidebands, they can do more things that we can't really do with SMBus, but it still may not be the best thing to do if you've got to transfer a significant log out, or if you're doing a firmware update and it's 32 megabytes or something. So I think there's still going to be use case where like PCI VDM is a great way to do higher speed, higher performance sideband stuff. But security, I think really having that true sideband, out-of-band interface like SMBus or I3C really gives you that isolation and protection So I think there's still going to be a need for that, predominantly driven by security.
Maybe to expound on it a little bit in the sense of, I think it's a little bit of it's belt and suspenders. So you could think of different failure modes in the drive. It's like, you know, as the host, I think the drive is just fine. And the drive says, wow, something just happened inside. I should probably let them know, right? So that's kind of in-band controller-initiated telemetry. So that would be, you know, it's a great way of kind of getting data out to the sense of what happened, and we'll figure it out, right? And then you can see, more where, say, the front-end processing engine of the device is wedged. I can't do any in-band. There's no, I can't do get log pages. I can't do anything like that. The out-of-band side signals, maybe I can still get in through the SM bus side to either, get some data out or even knock the processor on the head saying, you're not responding to me, why not? Things like that.
So what I'm hearing there is the benefit of the two avenues for debuggability is greater than the risk of two different avenues of attack for a drive in the security realm. Is that a general?
Yeah, I think in the sense of obviously you have to be cognizant of the whole security stuff and then making sure they're both hardened, but yeah.
Yeah, I think from an attestation, you need the out of band. I think that's common. And then there are cases where it's just way more convenient to have in-band, PCIe operations. Just that's where the application is, and you need some information that's critical to that use case. So I think there's definitely two at least.
And I think especially because like with SM bus or I3C, that's inherently more secure just because that's not usually connected to the host. That's good. That goes right to the BMC. So you kind of have that kind of physical isolation as well.
Thank you.
And I think the more we can align as an industry, the easier it'll be for everybody. With that, more questions?
So first of all, I want to thank you guys for working on this spec. I know before OCP existed, you guys would all independently have specs. They would almost align, but it still forces us to write the code a half a dozen times and validate it half a dozen times. So that's really good, thank you. If I got a bunch of vendors into a room and we tried to pick a spec, it would be the least common denominator of everybody. If I got all the host guys together to write a spec, it would be the upper common denominator of everything everybody wanted. Is there going to be any push-pull between getting the feedback of the requirements of now 5 companies that might be involved in contributing to the spec versus the vendors that are implementing this?
Anybody want to take that?
Ross, you don't want to take that? You don't want to take a stab?
I see you going for it, Paul.
I mean, I think that ultimately we as the purchasers of the drives all need to have our feature sets in there, right? So I think that is kind of the superset. And so I think that, as we try and work together, we're trying to make sure that we all have common feature sets that are required, that we're not putting in a bunch of stuff that no one else is going to use. We're trying to get to a point where we see value in all the features that we put in there. But ultimately, there may be some things that one of us needs that maybe somebody else doesn't. And at the end of the day, we want to make sure that that's there available. And over time, it may be adopted by more folks. And that also gives you a chance to make sure that when we're doing things like the testing and debuggability, that that's tested across a common firmware, and I think that's really valuable so that even if not everybody's using that specific feature at a given time, it's tested well and it's available there in the future for people to adopt as we move forward.
Yeah, I'd like to kind of reiterate that too. I think at any point in time, there's always going to be some divergence, right? And I think the value in this forum is like looking to the future, trying to to minimize those over time. To really be thoughtful about what where they exist, have to force those conversations of like why aren't we on the same thing, and is this going to be the same is this going to be the same thing 10 years from now or not? Whereas previously, like you mentioned, that we would have different requirements. This is 30-second timeout, that's 60-second timeout, and just because, right? We just didn't talk, right? So, it's not going to be perfect. There's still going to be probably differences in the end, especially in the short term. And but at least the senseless divergence, hopefully we can put an end to. So
I know today you guys have personality A, B. Maybe it's personality good, better, best instead. And
I don't look at it that way. I look at some of them are just fundamentally different requirements that we each have, and I'm not sure that there's really a good, better, best to that component of the A and B personality. But I do totally agree with what Chris said. I think it's a short-term thing, right? We have this long-term goal and I've said this multiple times, so it's kind of like a broken record, but the kind of one firmware to rule them all. And I think that is our long-term goal. We're not there today. We just are at 2.0, and on SAS and SATA, we're going to be at 1.0. But we're trying to get there. And I think over time, that's exactly what we're trying to do, is to converge our requirements. And we may not be there today, but we're working to get there.
Thank you, guys.
Okay, more questions. Oh, we got another question in the room.
Yeah, thanks you guys for being here, and thanks for the calls for more collaboration. One thing from the vendor side that I'd like to see, I appreciate them folks for more debuggability, but a lot of times when we appreciate the call for more logging, a lot of times when we put even things like smart, getting that back from our customers is like a black hole. Like, nope, we can't share that's IP, and so I'm very hesitant to go put and layers of counters, everything in there if I'm not going to get it back. And so how do we get to that point where, like, hey, we have an intelligent thought process about that, we get all that, more of a shared back and forth on that? Because today I have two types of failures. One's maybe the one that occurs in your data center that's subtle, and we've shipped you 1 million drives, and 3 years later, here's a trickle of these. Go fix it immediately. Well, that's going to be tough. Got to put in some new logs. Versus I actually get more failures from your ODMs that grew one bad block because they don't even understand basic smart. So I'd love to figure out the point where we get to like more of a collaboration on that part as too. And the more I give you, the more I get back, and we can really kind of both analyze what's happening in the world as opposed to contrast. I throw the drives over the fence and I wait for a fail to occur and hope I can have the logs to fix it quickly.
You guys want me to go for this one? Sure. So, by the way, I completely agree with all your concerns. They are great concerns. It's a big problem. So if we start off with that as a baseline, I think there are a couple things. I think now that we have the OCP-based NVMe CLI, we have a common way of getting stuff off the device. That's a huge win. I think we need to continue that path. The next thing you pointed out is, how do I get my debug information back efficiently and effective?
And ideally, not just when it fails, but throughout, so I can kind of see a problem happening on the way.
And I think that feeds into the need of, you've heard a lot of discussion on debuggability and better and new methods. And I think that's an area that we've been pointing out as a problem, and you're pointing out the same problem, and it needs work. I don't think it's an unsolvable problem, but nothing happens overnight.
Fair enough.
But I agree that it's a big problem of you getting the information you need, and what about over time, and if we can get to better debuggability, human readable, things that fit better in people's ecosystems, it's going to be better for all of us.
Right. Thank you.
Thank you. More questions?
As you asked for it, what are the things that we could potentially work on for future? So I just want to hear your thoughts on computational storage. The panel's thoughts on computational storage as in the traditional way, or different ways that you might be thinking, either on bringing the compute next to the storage, or any other way that you're thinking.
Anybody want to comment on computational storage?
I mean, I can say something, but I don't think it's going to be profound.
Yeah, I'll kick it off, and then you can follow up,
sure.
maybe, Chris. So I think computational storage has been around for a very long time, right? We saw some of the first presentations probably 5-7 years ago at FMS. I love that we got standards now, right? That was one of the things that we kind of always continually pushed back. We saw individual vendors that came out with their own proprietary methods, and that just doesn't work for someone like an HPE, probably not for hyperscalers either. And so I love that we're getting to the point where we've got standards now. And so now it's kind of finding the killer app. I know, at least for us, because we've got to try and figure out how we focus to a customer to get a very specific use case for them. Because the way that our options business works, we put drives out there and customers buy them. They have to know why they're buying that specific drive. So I think for us, we're still trying to make sure that we can figure out where are the largest TAMs to go after, and how do we kind of get that information to our customers so that they can figure out how they go and use it. I think for our as a service business that's coming around like GreenLake, that's going to be a little easier because we're kind of our own customer there. And so we can implement things a little bit easier in that model, which is a little different than our traditional kind of enterprise business.
I think we've been looking at it for a while, but it's I think there's some challenges there, and so in particular, security becomes one. How do I, if data is encrypted, how does this work? And then another big one is just, a lot of the data center folks were scale out, and fundamentally, I think a lot of the accelerator stuff is scale up, make one machine faster, and so a lot of these workloads become distributed, and so the piece that you need to accelerate is elsewhere, and so it's a challenge. And I think, but on the flip side, I don't mean to sound poo-poo on all this. There's a lot of value, right, in terms of power efficiency. We saw the Postgres presentation. So if we can figure out a way to address those challenges, I think it could be powerful. It's just it's tough, I think, is what I'm trying to say, at least from our perspective. So
Let me add to that. I'd add that if somebody has the killer application that's under standards that they think is really interesting, come and talk to the OCP storage group. We meet once a month, and come show us, this is a killer application, here's why, it's standardized, lots of supply. I think that'd be something that would be very interesting to everybody. So if somebody has that, I'd encourage you to come bring it to the table. More questions?
Paul, you brought up the performance of the smaller drives isn't scaling, and so probably others have opinions as well, but I'll start pointing at you. So performance isn't scaling, but if you were to choose the bandwidth, throughput versus latency, what are you seeing as a more critical focus metric to start focusing on?
Yeah, so I think for the lower capacity drives that tend to be boot focused, so they have sort of a minimum requirement of bandwidth. It's not a huge amount, but I think that those are okay to be a separate kind of performance criteria, right? And that's what I was talking about earlier with the boot focused product. That could be something that we can more easily explain to our customers that, like, this is a boot focused product. Don't try and compare it to the low capacity point of this other drive family. The challenge that I think we're seeing on the performance front is more of not the boot focus, but like the standard capacity drives. So the 1 and the 2 terabyte kind of offerings, those are really falling off, moving forward. And we're seeing folks come in that say, hey, we want to do starting at 4 terabytes. Our customers have been buying 1 terabyte drives, and I say that, 960s and 800s, read intensive mixed use, but the 1 terabyte kind of class of drive, they've been buying that for years, and they still need to do that, moving forward. So even if they're not putting in new greenfield installations, they're still buying those same drives to replace older drives or to put it in that same kind of workload and environment. And so we need those lower capacities for a long time. And if all of a sudden that 1 terabyte drive comes in and it's like 40% the performance, right? It's a huge drop in performance, and they're like, hey, why is this drive that's 3 years old better than the drive that's coming out now? So that's the challenge that we're seeing with that. And so really it's kind of maintaining performance from previous generations for bandwidth. Latency is a little easier, I think, to kind of handle, to kind of stick with, but it's really the bandwidth that we start to see a problem where they're really coming down in performance from 2 to 3 years ago.
Thanks for clarifying.
Anything else here? Well, Amber, do you have closing comments? Is that where we're at on the schedule here?
I think we do. We have 2 slides maybe.
Okay. Thank you. Appreciate
Thanks,
all of you
everyone.
coming up here today.